Okay, so in example two, the directions say fill in the chart by converting between fractions, decimals, and percents. We want to show our work on paper. Okay, so for this situation, let's start with the percent. We have 350%. We can write that as a fraction by putting 350 over 100 because we know that percent means an amount out of 100. So we've got 350 over 100. Now, to write this as a decimal, we would have to take 350 and we would have to divide by, oh, try that again. We would have to divide, I'm going to go up here and still this division sign. There we go. We would have to go up here and divide 350 by 100. Okay, so we end up with 350 divided by 100. That's going to shift all of our digits to place values lower. So the 0 that was in the ones place is now in the tenths. And then when we shift again, it'll move to the hundreds. So rewriting it as 3.50 hundredths. All right, so now we have 25 thousandths as our decimal, and we want to be able to rewrite this as both a fraction and as a percent. Let's start with rewriting this as a percent. So now let's think. When we were going from a percent, which is an amount out of 100, we were dividing our percent by 100 in order to get our decimal. So what do you think we should do if we're going from decimal to percent? Correct. So when we are shifting from percent to decimal, increase this a little bit so that we can see our notes here. When we are shifting from percent to decimal, we divide by 100. If we're going from the decimal to the percent, we're going in the reverse. So from decimal to percent, we multiply by 100. So that means that I'm going to take this decimal, this 25 thousandths, and I'm going to multiply by 100. Well, once again, using our knowledge of place value, what that tells us is that our digits are once again going to shift. But this time, since we're multiplying, we're shifting in a way that our digits shift in a way that our digits now increase in value. Okay, so that means that our digits are going to shift to the left. And since we're multiplying by 100, our digits are shifting 2 times to the left. So what is starting out as 0.25, where our decimal is here all the way to the far left, now our digits are shifting not once, but twice, which allows our decimal point to go between the 2 and the 5. So we end up with this 2.5, or 2 and 5 tenths. And we can leave off this 0, and that's in the front now. So how do we write this as a fraction? Well, once again, our percent represents, this is 2.5%. This 2.5% represents 2.5 out of 100. So we could write this as 2.5 over 100. So now we have from a fraction. And what we're wanting to do is take this fraction and go from to a decimal, and then also converting it to a percent. Well, let's start by converting it to a percent, shall we? So if we're looking at this particular fraction, we've got 1 over 8. And we can essentially think about that as 1 over 8. Once again, I'm going to be down here in the notes section. So I've got 1/8, but I want to have 100 as my denominator because we're talking about percent being out of 100. So we can look at this almost like an equivalent fraction type of problem where I essentially want to go from having 8 in my denominator's place to having a 100 in my denominator's place. So then what do I multiply 8 by in order to get 100? Well, 8 times 12.5, that will give you 100. So what we do to the denominator, we also have to do to the numerator. So on the top, that is going to be 1 getting multiplied by 12.5 as well. So what we end up having is this 12.5 over 100 as our percentage. And I want to once again say that this is going to be our percentage. So we can write that here as 12.5%. Now, that does not mean that our decimal is going to be 12.5. We want to think about this really carefully. 12.5 is our percentage. That's how much out of 100. But to write this as a decimal, think about what we just learned. If I'm going from the decimal from a percent to my decimal, we have to divide. If we're going from our percent to our decimal, we divide. So that means that in order for me to determine what 12.5% is as a decimal, I would need to divide 12.5 by 100. And so what we would end up getting is these digits, once again, shifting, decreasing in place value. Because remember, anytime that we are dividing by a multiple of 10, we have this shift in a way that our digits decrease in value. Okay. And I'm going to add some arrows there in a little while to make that more concrete for the notes. So essentially what we had, which was 12 and 5/100 with the decimal in between the 2 and the 5, 12 and 5/10, goodness, with the decimal between the 2 and the 5, we're now going to shift these digits to where they're decreasing in value. So that means they're moving to the right. So not once, but twice, putting our decimal now in front of the 1. So our decimal form of 12.5% ends up being 0 and 125 thousandths. We're going to type that in to our chart here as well. So the key things that I want you to remember is that when we are working with percents, if we're shifting from percent to decimal, we're dividing by 100. That means our digits shift in a way that, well, it kind of says that all over again here, doesn't it? Okay, so we shift in a way that our digits decrease in value. So they decrease in value as we are moving to the right. Okay, that might help it be a little bit more concrete. Now, in the same instance, when we're moving from a decimal to a percent, I'll highlight that in a different color. Moving from a decimal to a percent, we multiply by 100. That means that we shift in a way that our digits increase in value. That would imply that we are moving to the left. Our digits are shifting to the left to increase. All right, so keep these in your notes because you are going to need this as you are working on that problem set. Go ahead and read the next slide and then continue on to the problem set.